Trigonometry. Trigonometry is derived from two Greek words, that is trigonon and metron, and this means measurement of triangles. So we are going to draw some triangles, measure them, then we'll establish some relationship or observe some patterns. We are going to restrict our measurement to right angle triangles for now. So kindly take your piece of paper or notebook and draw a right angle triangle. So this is mine. We need to obtain similar triangles so that we can get consistent results. So we divide this triangle into as many similar triangles you can. Divide your triangle into as many similar triangles you can. For the time being, I'll divide mine to only 3 similar triangles. So the measurement is going to be that of an angle and that of the size. So this is our first triangle. Let's measure the angle over here first. So this is approximately 53. 1, 2, 3. So 53.13 degrees. So we've gotten our angle to be 53.13 degrees. Yours might differ. Then now let's measure the size. So each box is 1 unit. So this is 1, 2, 3. So this is 3 centimeters. Then we measure this side 1, 2, 3, 4. So this is 4 centimeters. Now let's write down the ratio opposite over hypotenuse. So we can repeat the same thing for yours also. So the opposite to this angle is the 4, and the hypotenuse we don't know yet, but from Pythagoras theorem we can find the hypotenuse. You can also measure yours, but from Pythagoras theorem the measure of mine will be 5 centimeters. So over here we obtain the ratio opposite is 4 and the hypotenuse is 5. So this will give us 4 over 5. Now the adjacent over the hypotenuse, adjacent is 3. So you are going to get 3 over 5. Then the opposite over the adjacent will give us 4 over 3. Now let's do for that of triangle 2. So the angle itself the same, 53.13 degrees. So this side, the adjacent side will now be 1, 2, 3, 4, 5, 6. So this is 6 centimeters now. Then this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 centimeters now. Then this side will now be equal to 10 centimeters. So you can also measure the size of your right angle triangle. Then now let's take the ratio opposite over hypotenuse will give us 8 over 10, and this will simplify to 4 over 5. Now adjacent of hypotenuse will be 6 over 10, and this will simplify to 3 over 5. Then now the adjacent, the opposite over adjacent will be 8 over 6, and this will simplify to 4 over 3. Then for this triangle, the angle is still the same. So we have the measure of this side to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 centimeters over here, and this is 12 centimeters. So this will be 15 centimeters. Now we take the ratio again, opposite of hypotenuse. So this is the angle, the opposite is 12 centimeters over the hypotenuse, which is 15, and this will still simplify to 4 over 5. Then also this will give us adjacent is 6 over the hypotenuse 15, and this will simplify to 3 over 5. Then we have 12 over 9, and this will simplify to 4 over 3. So we can see that for all the ratios, the values are constant despite different sizes of the triangle. So that constant ratio is what we call the sine of the angle theta. I would like you to take your calculator and find the sine of 53.13 degrees. You see that it will be approximately equal to 4 over 5 if correct to 2 decimal places. Then also this constant ratio is called the cosine of the angle. The cosine of the angle. So let's say it cos 53.13. Yours might be different, your angle might be different, but you should get a constant ratio for this. And that constant ratio is what we call the cosine of the angle. Then so you can find cosine of 53.13, and it's supposed to be correct. It's supposed to be correct to 3 over 5 to 2 decimal places. Then also this constant ratio is called the tangent of 53.13 degrees. So we have measured our angles in degrees. There are other units of measurements like the radians, but we are going to deal with the degrees for now. So you can also find the tangent of 53.13, and you see that it is approximately equal to 4 over 3, correct to 2 decimal places. So far we have seen that the sine of an angle of a right angle triangle is equal to the opposite over the hypotenuse. Then the cosine of an angle is equal to the adjacent over the hypotenuse. Then the tangent of an angle is equal to the opposite over the adjacent. So we use the acronym SO CA TOA to remember the relationship between the sides in relation to the angle. You must commit these mnemonics to your memory because it can help you in our subsequent lessons.